Today's session is about formation of partial differential equation by elimination of arbitrary constants. Approach. First we have to check for number of arbitrary constants and number of independent variables. If both are equal, then we get unique linear PDE. If arbitrary constant is less than number of independent variables, then we get more than one partial differential equation of order 1. If arbitrary constant is more than number of independent variable, then higher order PDE is obtained. Here we make use of P and Q. Here we partially differentiate with respect to x and y. Then substitute the value of arbitrary constant to get to get required PDE. Let's understand case 1. If number of arbitrary constant is equal to number of independent variables, then unique PDE is obtained. Let's understand it with examples. In this example, A and B are a number of arbitrary constant. A and B are arbitrary constants. So here number of arbitrary constant is 2. X and Y are independent variables. Number of independent variable are 2. Z is dependent variable. Here number of arbitrary constant and number of independent variable are equal. So we get unique linear PDE. Here we make use of P and Q. P is equal to dou Z by dou X and Q is equal to dou Z by dou Y. Now we'll do partial differentiation with respect to X. So Z becomes dou Z by dou X. Here AX. AX on differentiation becomes A is constant and X differentiation of X is 1. So we get 1 into A is A. Here BY. Differentiation of Y with respect to X, then y will be considered as a constant, so differentiation of constant is 0. So this term again is constant and this is also constant, so differentiation of this also becomes 0. So we get dou z by dou x is equal to a. Dou z by dou x is p, so we get p is equal to a. Similarly, partial differentiation of this equation with respect to y, z becomes dou z by dou y. Ax, here x is constant because we are differentiating with respect to y. By becomes b and these two again constant, so these terms will become 0. So dou z by dou y is b. This is equal to q. So q is equal to b. Now substitute the value of a and b in this equation to get required PDE, which is this. In this example, a and b are arbitrary constant, x and y are independent variable and z is dependent variable. So here number of arbitrary constant and number of independent variables are same. So here unique linear PDE is obtained. P is equal to this, Q is equal to this. Partial differentiation of this equation with respect to x. Z becomes dou z by dou x. Ax cube becomes 3x square a. 3ax square. So this is equal to P and this we are writing it here. Here in this question it's x cube is given. So we'll multiply both the side with x. So we get 3ax cube plus px. Bring this 3 down here. So ax cube is equal to px by 3. Now we have brought this in the form of ax cube so that it will be easy for us to substitute here. Now partial differentiation of this equation with respect to y, z becomes dou z by dou y and this x becomes constant because we are differentiating with respect to y, and so here this becomes 0. Byq becomes b into 3y square. This is q we know and this is by square. Now multiply both the side with by y. So we get 3by cube is equal to qy. Bring this q down here. So by cube is equal to qy by 3. So we'll call this equation as 2 and this equation as 3. Substituting 2 and 3 in 1, we get required partial differential equation, which is this. In this example, x square by a square plus y square by b square, a and b are two arbitrary constants. X and y are two independent variables. Z is dependent variable. Here number of arbitrary constant is equal to number of independent variable. Hence we get linear PDE. P is equal to this, Q is equal to this. On partial differentiation with respect to x, we get 2 remains the same because it's constant, z becomes dou z by dou x. Here x square becomes 2x, and this a square is 1 by a square, which is constant, so it will get 2x by a square. Now this, instead of dou z by dou x, we'll substitute p. So 2p is equal to 2x by a square. This 2 and this 2 get cancelled. So we get x by a square is equal to p. Now bring this p here and bring this a square here. So we get this. Now partially differentiate with respect to y. We get 2 here, and z becomes dou z by dou x. This term x will become constant. This is x is constant, so this term will become 0 because we are going to differentiate with respect to y. And this y square becomes 2y, and b square is 1 by b because it's constant. So we get 2y by b square, and this we can put it as q. So 2q is equal to 2y by b square. Here 2 and 2 get cancelled. We get q is equal to y by b square. Bring this b square here and q here. We get y by q is equal to b square. Now we got the value of a square and b square. So we'll put the value of a square and b square here in this equation. So required PDE obtained is, in substituting, we get 2y is equal to px square by q plus qy square by y. This x and this x get cancelled, this y and this get cancelled, and so we get this which is required PDE. In this example, a and b are arbitrary constant. Number of arbitrary constant is equal to 2. X and y are independent variables. Number of independent variable is equal to 2. Here number of arbitrary constant is equal to number of independent variable, hence we get linear PDE. P is equal to this, Q is equal to this. On partial differentiation of this with respect to x, we get dou z by dou x. And this is product of two terms. So here product rule of differentiation is used, and we get y square by b square is equal to 2x. This is equal to p. So p is equal to this. Bring this 2x down here. So p by 2x is equal to this. Partial differentiation of this with respect to y. Here z becomes dou z by dou y. This and these two are product of two terms. So here product rule of differentiation is used, and we get x square plus a square times 2y. Dou z by dou y is q. So q is equal to this. Bring this 2y down here. So q by 2y is equal to this. Now substitute the value of 2 and 3 in equation 1. That is the equation 1. Here x plus a square, that is this value, is equal to q by 2y. So q by 2y we have written. Then y square plus b square, this value we are writing p by 2x. Now multiplying this 2 and bringing it here. So we get 4xyz is equal to pq. This is required PDE. In this example, x and y are independent variables. So here number of independent variable is equal to 2. A and B are arbitrary constant. Here number of arbitrary constant is equal to 2. So here number of arbitrary constant is equal to number of independent variable. Hence linear PDE is obtained. Let P be this and Q be this. On partial differentiation of this with respect to x, we get this becomes 2x minus a, and then differentiation of x, that is chain rule, is 1. So we get this. Here differentiation of this term, here since y, since we are differentiating it with respect to x, this y will be considered as constant, and differentiation of constant is 0. So this term will become 0. Z square will become 2z, and then chain rule, differentiation of z is dou z by dou x. Simplifying this, we get 2 times x minus a is equal to minus 2z dou z by dou x. This 2 and this 2 will get cancelled, and dou z by dou x is p. So we'll substitute that. We get x minus a is equal to minus zp. Partial differentiation of this equation with respect to y. This term will x will be considered as a constant because we are differentiating with respect to y. So this term will become 0. Here the y, this term y minus b, so this will become 2 into y minus b, and then differentiation of y is 1. So we get this. And here z square will become 2z, and then differentiation of z is dou z by dou x. We get this. Simplifying this, we get this, and this 2 and this 2 will get cancelled. We get y minus b is equal to minus z q. Now substituting 2 and 3 in 1, we get this. Now take z square out as common. We get p square plus q square plus 1 is equal to 4. This is required PDE. In this example, a and b are arbitrary constant. So here number of arbitrary constant is 2. X and y are independent variable. Here number of independent variable is 2. So arbitrary constant is equal to number of independent variable. So we get linear PDE. Let P be this, Q be this. Partial differentiation of this with respect to X is Z will become dou Z by dou X. Here A into, when we differentiate this, it is 1. When we differentiate this, it becomes 0, and this also 0. So we get A. Now partial differentiation of this with respect to Y. Z becomes dou Z by dou Y. This is A, and differentiation of this here will become 0, and differentiation of this is 1. So we get A. Now we got P is equal to A and Q is equal to A. Equating 2 and 3, we get P is equal to Q. So this is required PDE. In this example, A and B are arbitrary constants. X and Y are independent variables. Here number of independent variables is equal to number of arbitrary constant. So we get linear PDE. P is equal to this, Q is equal to this. Partial differentiation of this with respect to X. Z becomes dou Z by dou X. Here this term a and e to the power y are constant, and differentiation of x is 1. So using constant multiplication rule, when we differentiate this, we get a e to the power y. Here this term, here this is constant, this is constant. Since we are differentiating with respect to x, this is all, this y term also will become constant. So when we differentiate constant, we get 0. So this term becomes 0. This is constant. This term also becomes 0. So we get dou z by dou x is equal to a y. This is p. So p is equal to a e to the power y. Let's name it as equation 2. Partial differentiation of this term with respect to y. Z will become dou z by dou y. Here in this, a and x will be considered as a constant because we are differentiating with respect to y. E to the power, differentiation of e to the power y is e to the power y. So we get ax e to the power y. In this term, 1 by 2 is constant, a square is constant. E to the power y, when we differentiate it, we get 2 times e to the power 2y. So we get this. And b is a constant. When we differentiate b, we get 0. So on differentiation, partial differentiation of this, we get this. Now here this 2 and this 2 will get cancelled. So finally, and dou z by dou x, dou z by dou y is q. So q is equal to this term, and here this 2 and this 2 get cancelled. We get a square e to the power 2y. This can be written as e to the power y whole square, and then Here a square is there, this square is there. So altogether we can write it like this also. So x a into e to the power y plus this one a e to the power y whole square. Now substituting 2 in 1, that is here p is equal to a to the power a into e to the power y. So a into e to the power y will put it as p. So here q is equal to x into p plus p square. This is the required partial differential equation. Now we'll take an example with log. So a times x plus log y minus x square by 2 minus b. Here in this example, arbitrary constant are a and b. Independent variable are x and y. Z is dependent variable. Here number of arbitrary constant is equal to number of independent variable. So we get linear partial differential equation. Now P be this, Q is equal to this. On differentiating with respect to x, so Z will become dou z by dou x, and here a differentiation of x is 1 and differentiation of log y with respect to x is 0. So we get a minus here x square becomes 2x and this 2 will be remain the same. So we get 2x by 2. This term will become 0. So we get this. This is p is equal to a minus 2x by 2. This 2 and this 2 can get cancelled. So p is equal to a minus x or a is equal to p plus x. We can name this equation as 2. Now partial differentiation with respect to y. Z becomes dou z by dou y. Here this term a will be there and this x on differentiation with respect to y will become 0 and log y is 1 by y. And this term is x, so it will become 0. This is also 0. So we get q is equal to a by y. So a will be equal to q y. So here a and a equating 2 and 3. We get p plus x is equal to q y. This is the required partial differential equation. A and B are arbitrary constant, x and y are independent variables. Number of arbitrary constant and number of independent variable are equal. So we get a linear partial differential equation. Let P be this and Q be this. Partial differentiation of this equation with respect to x. Here in this term, 4 and this 1 plus a square is constant. So here we will be using constant multiplication rule while doing differentiation. So we get 4 dou x by dou z by dou x is into 1 plus a square is equal to, here this on differentiation this will become 2 into this term, 2 into this term, and then again we have to differentiate each term here. So differentiation of x is 1. So we write here 1. Differentiation of ay is 0. Differentiation of b is 0. So here 1 into this term we get this equation. Here this is p. So substituting the value of p, substituting p, we get this x equation. We name it as 2. Partial differentiation of this with respect to y, we get 4 dou z by dou y into 1 plus a square. This is constant multiplication rule while differentiating this is equal to 2 into this value. So 2 into this value. Now we have to differentiate each term here. Differentiation of x with respect to y is 0. Differentiation of y is 1. 1 into a is a. So we'll write here a. And differentiation of b is 0. So we just leave it. So we get this equation. And here dou z by dou y is q. So we get this. Now we have to divide 2 by 3. So 4 and 4 will get cancelled. 1 plus a square and 1 plus a square will get cancelled. 2 and 2 will get cancelled. X plus ay by b and x plus ay by b will get cancelled. So we get p by q is equal to 1 by a, and we'll call this equation as 4. Now this is equation number 1. And equation number 2 says, equation number 2 is this. So here this value will be equal to this value divided by 2. Okay, so x plus ay plus b is equal to 4p 1 plus a square divided by 2. Now we'll place this value in the place of this. So we get this. Now simplify it. It's 2 times 4. So we get 2p 1 plus a square whole square. Now 2 square is 4. P square is p square. 1 plus a square is to the power whole square. Now here 4 and 4 will get cancelled. 1 plus a square and 1 plus a square will get cancelled. So we get z is equal to p square 1 plus a square. Now we'll substitute the value of a. From equation 4 we know a is equal to q by p. So we are putting the value here. So q square by p square. So and then taking LCM of this, we get this. So z is equal to p square. This p square and this p square will get cancelled. So z is equal to p square plus q square. And this is required partial differential equation. In this example, a and b are arbitrary constant, x and y are independent variable. So number of arbitrary constant is 2, number of independent variable is 2. So both are same. So we get linear partial differential equation. Now let's take this equation as equation 1. Let p be this, q be this. Partial differentiation of this with respect to x. Z is dou z by dou x is equal to 1 by 2 is constant, so we'll keep it out. Differentiation of this is 1 by 2 under the root x plus a, and differentiation of this is 0 because differentiation of y with respect to x will be 0, and this is again constant, so differentiation of constant is 0. So we get this dou z by dou x is p. So p is equal to, here these two we are multiplying, so 1 by 4 under the root x plus a, and we'll call this equation as equation 2. Now partial differentiation of this with respect to y. So z will become dou z by dou y is equal to 1 by 2 will be here. This term will become 0 and this term will become this plus 0. So and dou z by dou y is q, and here this 1 by this 2 and this 2 will become 4, and under the root y minus a, and this equation we'll call it as equation 3. Now we know p is equal to this. Now squaring on both the sides we get this. Now x plus a is equal to this and a will be equal to this. So we'll call this equation as equation 4. Similarly for q, squaring on both the sides, then bringing y minus a this side, and a is equal to this. This equation we call it as 5. Now here this is a, this is a. Now we'll equate 4 and 5. Equating 4 and 5 we get 1 by 16 p square minus x is equal to y minus 1 by 16 q square. Bringing this term here and bringing this here, we get 1 by 16 p square plus 1 by 16 q square is equal to y plus x. Taking LCM of this, we get this. Okay, then bring this here. So p square by q square is equal to 16 p square q square into x plus a. This is our required PDE. Now form the partial differential equation by elimination of a and b from this equation. Here a and b are arbitrary constant. X and Y are independent variables. Here number of arbitrary constant is equal to number of independent variable, and so we'll get linear partial differential equation. Here this alpha, it is constant and we need not eliminate it. Let P be this and Q be this. Partial differentiation with respect to X. So here this term will become 2 into x minus a plus this term y term will, because we are differentiating with respect to x, so this y becomes 0. So we'll write it here 0 is equal to z square. Z square will become 2z, and then again chain rule, we have to differentiate z. Z differentiation of z is dou z by dou x, and this is constant, so we'll just keep it as cot square alpha. Simplifying this, that is this and this will get cancelled. X minus a is equal to z dou z by dou x cot square x. So this and in dou z by dou x we can put it as p, and we'll name this equation as equation 2. Now partial differentiation of this equation with respect to y. Here this is x. So when we differentiate with respect to y, this x will become 0. So the whole term will become 0. And here it will become 2 into y minus b. And then again differentiation of y is 1. So we get 2y minus b into 1 is equal to, here z square will become 2z, and then again differentiation of z is dou z by dou y, and this is constant, we'll keep it as such. Simplifying it, we get y minus b is equal to z dou z by dou y cot square alpha. This dou z by dou y we can replace by q. Now this equation we will call it as equation 3. So z square and cot square, it is common, so we'll take z square cot square out. So we'll get p square cot square alpha plus q square cot square alpha is equal to z square cot square alpha. Now this z square cot square alpha and this one get cancelled. Now we are left with this. Now here again cot square alpha and cot square alpha is common, so we'll take it out. So we'll get cot square alpha is equal to p square plus q square is equal to 1. Now p square plus q square is equal to 1 by cot square alpha. 1 by cot square alpha is tan square alpha. This is our required partial differential equation. This example says form the partial differential equation of all planes passing through the origin. So here they have asked us about PDE of all planes passing through the origin. Solution. We know the general equation of plane is ax plus by plus cz plus d is equal to 0. Here a, b, c and d are all constants. Now here they have specified it passes through origin. So 0, 0, 0. So then d is 0. So equation becomes ax plus by plus cz plus 0 is equal to 0. So we can say that ax plus by plus cz is equal to 0, and we'll consider this as equation 1. Now divide equation 1 by c. A by cx, b by cy, c by cz. Now a by c we'll consider as a dash, b by c we'll consider as b dash, and c we have to consider that it is not equal to 0. Now here the equation becomes a dash x plus b dash y plus z is equal to 0. We'll call this equation as equation 2. Here when we see a and b are arbitrary constant, which is 2. There are two arbitrary constant. X and y are two independent variables. Z of course is a dependent variable. So here number of arbitrary constant, number of independent variable are same. So here we'll get linear PDE. Now P is equal to this, Q is equal to this. Let's differentiate this equation with respect to x. So a dash x, differentiation of a dash x becomes a dash, and differentiation of b dash y. Here y is a constant because we are differentiating with respect to x, so this term will become 0. So we get 0. Differentiation of z is dou z by dou x. Now, so dou z by dou x is equal to p. So a dash plus p is equal to 0, which means a dash is equal to minus p. Let's call it as equation 3. Now similarly, we'll do partial differentiation of this equation with respect to y. When we do partial differentiation of this with respect to y, this term becomes 0, this becomes b dash, and z becomes dou z by dou y. Dou z by dou y is q. So 0 plus b dash plus q is equal to 0. So b dash is equal to minus q. This is equation 4. Now substitute equation 3 and equation 4 in equation 2 in this equation. We get minus px minus qy plus z is equal to 0. So z will be equal to, bring this to this side, we get px plus qy. This is required PDE. In this example, they've asked us to form the partial differential equation for all the spheres having centers lying in xy plane and having constant radius. So we know general equation of sphere is this, that is x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. Here a, b, c and c are centers. So a, b, c we can write like this. Centers we can write like this. And r is radius and it is given as constant. All the spheres center lying in xy plane. So everything is lying in the xy plane. So nothing is there in z. So the z coordinates will be 0. So we can write as here a, b. These two are lying in x plane, and c nothing is there. So we'll consider it as 0. So the equation will become, this is the general equation. Now we'll put the value of c is equal to 0 in this equation. So we get this equation. Now simplifying it, we can write like this, and we'll call this equation as equation 1. Now here number of arbitrary constant are a and b. A and b are arbitrary constant and number of arbitrary constants are 2. Here independent variable are x and y, and number of independent variable is equal to 2. So here both number of arbitrary constant and number of independent variable are equal. So we get linear PDE. Let P is equal to this, Q is equal to this. So partial differentiation of this equation with respect to x. When we differentiate it with respect to x, this term will become 2 into x minus a. Then again we have to use chain rule and differentiate this. Differentiation of x is 1 plus differentiation of this term. Here y, when we differentiate with respect to x, this y will be considered as a constant. So differentiation of constant is 0. So this b is also constant. Differentiation of constant is 0. So this term will become 0. Here z square will become 2z. Then chain rule. Differentiation of z is dou z by dou x. So we get this equation. Simplifying it, we get this. X minus a is equal to minus zp. We'll call this equation as 2. Now partial differentiation of this with respect to y. When we differentiate it with respect to y, this term will become 0, because when we differentiate with respect to y, x will be considered as constant and a is already constant, so differentiation of constant is 0. This y minus b will become 2 into y minus b, and then again chain rule, we have to differentiate y. Differentiation of y is 1 plus z square. Z square will be 2z, and then differentiation of z is dou z by dou y. Simplifying, we get this. Now substitute 2 and 3 in equation 1. So this is the equation 1. So here we are substituting the value of this and this here. So we get this. Now take z square common out, we get this. This is required PDE. Now in this example, form the partial differential equation of all the spheres having center lying in z axis. So here we know for any general equation of sphere is this. And here all the spheres have center lying in z axis, which means x axis and y axis will we have to consider as 0. So only c will be there, and radius is constant. Now equation of the sphere is this, we know. Now we'll put this value here, value of a and value of b here, and c will consider the c in this equation. So we get this. Now simplifying it, we get this. Here number of arbitrary constant are c. Here number of arbitrary constant are 2. That is c and r are arbitrary constant. So here number of arbitrary constant are 2. Number of independent variables again 2, and number, because x and y are independent variable. So here number of arbitrary constant is equal to number of independent variable, hence linear PDE is obtained. Here let p is equal to this and q is equal to this. Partial differentiation of this equation with respect to x. So x square will become 2x. This term will be 0 because when we differentiate with respect to x, y will be considered as constant, and differentiation of constant is 0. Z minus c, this will become 2z minus c, and then again differentiation of z is dou z by dou x. Simplifying this equation, we get z minus c is equal to minus x by p. Partial differentiation of this equation with respect to y is here. Now since we are differentiating with respect to y, the x term will be considered as constant. So constant differentiation of constant is 0. So we'll put it as 0 here. Plus this y square will become 2y, plus this will become 2 into z minus c. And then again differentiation of z is dou z by dou y. Simplifying this, we get z minus c is equal to minus y by q. From 2 and 3, we get this. That is minus x by p is equal to minus y by q. This minus and this minus will get cancelled. Cross multiplying, we will get qx is equal to py. And this is required partial differential equation. Case 2. If number of arbitrary constant, number of independent variables, then we get more than one partial differential equation of order 1. Let's understand this with an example. We have taken this example. We'll call this as equation 1. Here x and y are independent variables. Number of independent variable is 2. Z is dependent variable and a is arbitrary constant. Here number of arbitrary constant is 1. So here number of arbitrary constant is less than number of independent variables. So we'll get more than one partial differential equation of order 1. Let p be this and q be this. The partial differentiation of this with respect to x. So z becomes dou z by dou x is equal to ax. Differentiation of x is 1 and a is constant. According to constant multiplication rule, we get 1 into a, that is a. Here this is p, so we'll get p is equal to a. We'll name this equation as 2. Partial differentiation of this with respect to y. So z becomes dou z by dou y, and here when we differentiate x with respect to y, it becomes it is considered as a constant, and differentiation of constant is 0. So this term becomes 0. Plus y differentiation of y is 1. So we get dou z by dou y is equal to 1. Dou z by dou y is q, so we get q is equal to 1. Here when we see here there is no arbitrary constant, so we'll consider this as one of the partial differential equation. Now substituting 2 in 1. So z is equal to a value is equal to p, so we get z is equal to px plus y. So z is equal to px plus y. This is second partial differential equation. So in this case, we are getting more than one. That is two partial differential equation of order 1. Now let's take the example of, let's consider the case 3. If number of arbitrary constant is equal to number of independent variables, then higher order partial differential equation is obtained. Let's take this example. This example I have taken because this question is asked repeatedly in exams. So let's call this equation as 1. Equation 1. Here A, B, C are arbitrary constant. Number of arbitrary constant is 3. Z is dependent constant. Here Z is dependent variable, and X and Y are independent variables. Here number of independent variable is equal to 2. So number of arbitrary constant, which is 3, is more than number of independent variable, which is 2. Hence we get higher order PDE. So here partial differentiation of this with respect to x. This will become 2x by a square plus this term, when we differentiate y with respect to x, it will become 0. Z square will become 2z. This c square is constant, so it will be like this. Then again differentiation of z will be dou z by dou x. Now simplifying it, bring this term here. So it will become minus 2x by a square. Now this 2 and this 2 will get cancelled. Now bring this a square this side and c square this side. So we get a square z into dou z by dou x is equal to minus x, and this c square we have brought it here, so c square. So c square will be, bringing everything else this side, we'll get this. We'll call this equation as equation 3. Now partial differentiation of this with respect to y. So here when we respect x with respect to y, this term will become 0. Y square will become 2y and this b square remains the same. Plus here z square will become 2z and c square will, will keep it here, and again differentiating z will get dou z by dou y. So we have to after simplifying it, that is, we'll bring this term to other side. So we get minus 2y by b square. Here 2 and 2 will get cancelled. Now bring this b square here and bring this c square this side. So we get b square is equal to dou z by dou y is equal to minus y c square. Now put the value of now bring the c square here and take all the terms here. So we get c square is equal to this. We'll name this equation as 5 and this equation as 4. Now when we observe equation 5 and equation 3, we still have arbitrary constants. So we have to eliminate it. So we'll be partially differentiating it again. So first let's differentiate equation 2 again. So partial differentiation of equation 2, that is, we are differentiating equation 2 again partially with respect to x. So this a square is constant, so we'll keep it here. Now here z and dou z. Here the two terms are there, product of two terms. So here we'll be using product rule for differentiation. So first we'll differentiate z, which is dou z by dou x, into this term we'll keep it as such. So we are keeping it as such. Plus now z will keep it as such and differentiate this again. Differentiating this again will get dou square z by dou x square. And differentiation of this, minus will be minus. Here x, differentiation of x is 1. C square is constant, so we'll just write 1 into c square is c square. Okay. Now from equation 2, we'll put the value of c. So equation, according to the equation 3, c square is equal to this much. So this value we'll put it here. So we'll get this. Now simplifying it, this a square and this a square will get cancelled. This x we are going to bring it here. Then we'll multiply this x with this term and this term. So when we multiply x with this term, we get this, plus x term with this term is zx plus this term. And here this is plus, minus into minus is plus. So we'll get plus this value. But when we bring it to the other side, it becomes minus. So minus z, this here is z and this dou z by dou x. So this equation we'll call it as this can be a partial differential equation, one of the partial differential equation. Now we'll differentiate this equation 2 with respect to y. So here on differentiation with respect to y, this a square will keep it here, and now these two terms, again this is a product of two terms, so here product rule is used, and here we are differentiating with respect to y. So z differentiation of z with respect to y will be dou z by dou y into this term we are keeping as such, so we have kept it as such. Okay, now plus, now z we have to keep it as such and differentiate this with respect to y. So we get dou square z by dou x dou y. So we get this. Bring this a square here, so it will become 0. Now simplifying it, dou z by dou y into dou z by dou x plus z into dou square y by dou x dou y is equal to 0. So this equation is, this again one of the partial differential equation. We'll call this is second partial differential equation which we got. If we differentiate equation 4 with respect to y, we get this b square will keep it here. Here again the product rule. So z differentiation of z is dou z by dou y into this we'll keep it as such plus, now this we'll keep it as such and differentiate this, we'll get this is equal to differentiation of y with respect to y is 1. So 1 into c square is c square. This minus will minus can be kept here. Now c square value we can put from equation 5. Now it's written here 3. This is equation 5. From equation 5 we can get this. So substituting the value we get this. This b square and this b square will get cancelled. Now bring this y here and multiply this y with this term and this term. So we get y into dou z dou by dou b whole square plus y z, that is zy into this term minus this minus and minus will become plus, and when we bring it to this side of the equation it becomes minus, z is there and dou z by dou y is equal to 0. So we get one more partial differential equation. We can name it as partial differential equation 3. So here we got 3 higher order or second order partial differential equation. In example, if they have not specified, if you get even one partial differential equation, that is enough. But suppose if multiple question is asked and you have asked to get the choose from the choice, then you will need to do all the 3.